Through this recording, I'm going to cover some of the concepts covered in Chapter 14 of your textbook on JavaFX basics. Of course, your video notes that you receive from your textbook, if you bought your textbook new and you have the online access code, you can also look at some of the material posted by the author on this and other chapters. So essentially this chapter is all about creating a program with a graphical user interface or a GUI interface and essentially allowing you to create Windows type applications where we have we can have labels and text fields and buttons and labels and menus and all sorts of components that a graphical user interface uses. So as far as JavaFX is concerned, JavaFX is essentially a new platform or a new framework, a new set of API or libraries that essentially give you a set of enhanced libraries or essentially classes that you can use to create a graphical user interface. Through this chapter, you also see how, again, we use the concept of object-oriented principles of using objects, or essentially classes, created by others by writing your own or creating your own objects. So that's what this chapter is all about, and essentially your book gives you a little history of the Swing applications, or essentially Swing library and AWT, or the Advanced or Abstract Windows Toolkit. There were a set of libraries that have evolved from the first versions of Java to JavaFX. So these days we all use the JavaFX platform or the JavaFX libraries to create our graphical user interfaces. So the basic structure of JavaFX, essentially we have an application that we essentially inherit from. We override the start method, which allows us to essentially run our application. And the overall concept is based on the concept of stage. So you could think of a stage as a window or as a platform or as an area in which you place one or more scenes. So a scene is placed onto a stage. And then a button is a control or a node that could be placed on a scene. So essentially think about your nodes or components like buttons and labels and text fields, radio buttons and checkboxes, all as components that could be placed on a scene. And then we take that scene and place it on a stage, and then we essentially show the stage. So this is how we build things. We start with nodes placed in scenes, and scenes placed on a stage. So the first example I want to show you is this my JavaFX program, which is a pretty standard or pretty straightforward application. Notice again, you've got a whole bunch of import statements. Of course, as you know, anytime you use a class, you must know that it has to be imported into your Java program. So notice we start with public class myJavaFX. That's just the name of my file. Remember, extends means inherit from, and we're inheriting from a class called application. Now this class application has a method called start. So essentially what we're doing is we're being forced, essentially all programmers are forced to have this method named start with their own code. So that's what you see. And then we have this main program that actually launches the application. So you'll see that most of our main functions essentially launch to this application. So when I compile this, I compile it the same as usual. You just go external tools and compile. and you run a GUI application just like you would any other application that we've looked at so far. And then, so in order to run this, I'll go click on External Tools and run the Java application. And it's launching the application. This was my print statement. Notice you can also use system.out.print statements to kind of debug your code and see what's happening to various objects as you write your code. So that's just a debugging tool, really, in a test environment. And notice what it did is that it gave me a window with a default size. I can extend the size of the window. The window already has a title, the minimize, maximize, and close buttons, and OK, and a button that I placed. So the nice thing about this the JavaFX library is that we already are given this platform, essentially this window to work with. So let's go ahead and see what happened with this program. So we created a button. Now this should be very familiar to you, because all we're saying is create an object, in this case BTOK, from a class called button. So we just have to make sure that a button is essentially imported. Notice I have import javafx.scene.control.button. And again, if you want a label or a text field, then you have to import individually, or you could say .control star to give us everything within the control package. Okay. Now notice, remember we have to create a scene, so we say scene. Of course, this is just an object name, and what we do is we place on the scene a button. In this case, button OK, and we provide a size in pixels. This says 200 horizontally and 250 pixels vertically. So let's just take a look at this, because a window in essentially, as far as the JavaFX library is concerned, this is referred to as our x-axis or horizontal axis. This is our vertical axis or y-axis. This right here is our position 0, 0. So when we say something is 200 pixels, that means this width is 200. And then I think we said the other one was 250, so that means the height is 250. So essentially it gives us a window. So if I drew this line, I know it's kind of jagged right there, that's what we have as far as our window is concerned. Of course, remember that right there we had our title bar and the minimize and our control buttons. So if I go back to my program, that's what's happening, is that I'm creating the scene with this button in it, and then of course, notice in this example, I commented this, but you can go ahead. I will give you all these files, of course, so you could uncomment this and comment this and uncomment this, just to see what the default window size is. Set title, my JavaFX, that's what this title is right there. Of course, you could do change it with anything you want. Notice we're saying primary stage. This whole thing now is the stage. This entire window is the stage. So we put the scene in on the stage. So that's what we call a method called set scene with the scene. And then finally we show the primary stage. So, and then that's where we get the button OK in there. So now notice if I comment this line and run this, notice there's nothing to be shown because we chose not to show the primary stage. So as you can think, I guess you could kind of see this, is that we can actually show windows or stages based on maybe conditions. Again, we're not going to get to that in this class, but that's what this primary stage show is. So really, this is the structure of a Java GUI application. Again, the idea is to create a scene, create nodes or components, place those nodes in a scene, and then place the scene onto a stage, and then finally show the stage. Okay, the next one is a file called Multistage demo, and this is just a way to show you that we can actually create multiple stages. Notice I have a primary stage. Again, notice primary stage comes from the argument of the start method, and looks like here I just created a new stage. So notice that stage. Again, these two obviously are two different things, and then it says set the title to second stage, and then set the scene to be a new scene. And again, what I did was here I could have just taken this statement and actually created a button and then placed that button like we did in this example. But again, as you know, we can actually call an object and then use this value and pass it to another method. So if I ran this, you'll notice that we're going to have two stages. So this is my JavaFX stage, and then the other one, of course, is right there. And the good thing is you can move them. By the way, there's a whole bunch of things we could do, or we could make sure that these are not resizable or they're not movable. But again, if you know the methods within these classes that allow you to do various things, that's how you could do that. But again, we won't cover that in this course. But that's an example of a multi-stage demo, just to show you that we can have different stages or think of different windows. So you can think of as a a data entry window to enter maybe account information, and another window to import to enter maybe address information, something like that. So let's go back to here. So the next thing, essentially this picture is really good if you kind of maybe get a printout of it and keep referring to it. And again, this is what we were just talking about, is that the whole idea of a window being the stage, the scene being placed in the stage. The parent, essentially the parent could either be a pane or a control. As one of these, you can place those on a scene, and then we could put nodes, which could be essentially nodes could be shapes or images or controls. Now, when you look at this, a scene can go on one or more stages. So you can imagine on a stage we can have multiple scenes. So if you think of a theater situation, on a stage, you can have different actors playing different parts, maybe, or different scenes being placed. So that's that idea. And then you notice that a parent, which is either a control or a pane, could be placed on a scene. And then a parent essentially inherits from a node. Now, one thing you can see from here is that I cannot place a shape or an image view directly on a scene. I have to put these on a node and then put the node on the scene. As a matter of fact, we can also put the node in a pane and then put the pane on the scene also, which we'll talk about these various panes. So think of shape as lines, circles, ellipses, and all that. Image view is essentially a class. Again, by the way, these are all classes, predefined classes. Image view allows you to manipulate images. Controls are your user interface controls, such as labels and text fields and buttons and all checkboxes. So if you go to, of course, any one of these, like this is, these are all icons, and as a matter of fact, this right here could be a label, and then this is like a Dropbox. So that's what we mean by controls that we could place on our windows. And then panes are flow pane, grid pane. These are different types of layouts of your components. And you'll see that there is a default layout, and then we can actually change our layout so that our components could be placed properly on a window. So this example of button and pane.java, notice again you have a stack pane, and I think we just looked at that. The stack pane is actually a type of pane. So we say stack pane is a new stack pane. So essentially all it is we're saying that this variable, this is an object of this class. Now stack pane actually looks like a list of items. So here when we say pane.getChildren essentially says, give me access to the first element of that list. And of course this should be familiar. That looks like an array list. So what we're doing is we're adding a button labeled OK to the pane. So our pane, which is a stack pane by the way, right now holds a button named OK. Then I add a button named C, and then I create a scene, and then I set the title. Again, I show it. Now notice here it says set resizable false. Notice what happens when I essentially compile and run this. So I get this window, and remember a moment ago I could actually resize this window, but I can't do it anymore because I said resizable is false. And now because we use the stack pane, it actually stacked those labels. The button C is over actually this button OK, so it's kind of covering it. So as you might guess, the stack pane is probably not a very good pane class, or not a good class to essentially create objects from, because we don't have control of where to place these various controls or various nodes. So you'll see when we look at this example, my flow pane, or I think show grid pane, you'll see that we could create a grid and then place all of our labels on a grid or like a matrix. But I'll show you that momentarily. All right. So if you want to display a shape, and this is what I was trying to get at, is that with this, again, remember this is the X and the Y axis. This is our location 0, 0. So that's our the top left corner 0, 0. The conventional essentially Cartesian coordinate system has 0, 0 in the middle, but of course in Java coordinate system it's different than our traditional coordinate system. This helps you, by the way, as you start drawing things or placing labels, is you know where things go. So if I look at show circle.java, you'll notice that I'm creating a circle. Now this circle class actually comes from this Java API under shapes, and essentially I can set the center of the circle to 100, 100. So if you can imagine, the center of this circle is going to go at position 100, 100. So that's 100 pixel to the right on the x-axis, 100 pixel to the left. So the center of the circle would be right there. Then, if you look at the circle needs a radius, so you look at that, and the radius of the circle is 50. So if this allowed me actually to draw a nice circle, I'm drawing the circle just like that. Of course, Java can do a better job than I just did. So that's what we're going to get, the circle with a radius of 50, positioned, centered at 100 and 100. Okay, so that's our circle. Notice I can set the stroke. Again, that's just the boundaries of the circle to black. You can play with these fills. The default is black. You can change the set fill to red if you want, and that will give you a different color of the circle. Again, notice here's our pane. And then we say get the children of the pane. Essentially it says give me the first child and add a circle to it. Then I create another circle called C2. I'm going to make it blue, and I'm going to get this next child, or essentially the next array element, and add C2 to it. Again, the scene is essentially a 400 by 400 pixels, and the idea is to set the scene to the scene that we just created. So again, I hope you understand the process of creating essentially objects like circle, adding those objects to the pane, taking the pane and add it to the scene. As a matter of fact, scene right here is the pane. So the pane goes into the scene, and then the scene goes to the stage. So hopefully once you try, once you read up your book and look at these examples, you can get the idea of how that works. So this is so I've got my blue circle and the red circle, and they overlap just because of the way I've placed them. Now notice this window can be resized, and that's not a problem at all because I didn't set the resizable to false. So the default essentially is that you can resize a window. Okay, so that's an example of displaying shapes. Binding properties, these slides are starting from slide 8 all the way to 13. We're going to skip those. Notice we have a color class, we have a font class. Again, you can read those on your own, but you won't be responsible for them as far as assignment goes or exams are concerned. The image class is kind of nice. I think we might have a homework assignment that deals with image class. Again, any of these, by the way, they're not hard to do. It's just that, we could look at these demos and see how you create an object, and then you place that object or associate that object with another object or another class. So notice the image class has some attributes, and in this case you have a constructor, and then the image view class essentially allows you to view the image. So let's look at this show image so you can see how the process is created. So again, all of this is going to look very much the same. Essentially, we extend the application and we override the start method. Okay, so pane, new HBox. Well, let's see. If I go back to my slide here, did I have a HBox as a pane? So if we go here, did this view show us? Sure enough, HBox is a pane. And as you might expect, this allows us to create a horizontal box. So think of it as a maybe I could do a table with just one row. So this is what we mean. The components will be placed horizontally from left to right. Of course, if you had to guess, a vertical box would be something, or the V box would be something that goes like essentially this way, vertically. So again, you place your components vertically or horizontally. So let's go back in here, and it says we're creating a horizontal box with this spacing of 10 pixels. Again, these values of the constructors, essentially what the constructor expects, it all depends on how these constructors are defined. So for every one of these usages, we really have to go look up the documentation and hopefully see how they're used. If you can imagine set padding, by the way, for the padding, you can actually go to your book in chapter 14, and it shows you a nice example of how padding works. So we're creating an inset with pixels of 5 pixels with gaps from the, this goes top, left, I believe, bottom, right. But we'll see other examples of that. But that's just to set the padding of the pane. Now this is what we were just talking about. Image class allows you to create essentially an image object from a given file. Now this us.gif is actually in a folder under another folder named image, under the same folder where I'm actually running this code from. Of course, you can place your images in any given folder and then give it an absolute path. If I take out the image slash, of course the us.gif and o.gif and x.gif have to reside in the same folder. And these are just regular GIF files that you can replace with anything you like of your own images. Now again, look at this. You're saying get the pane or access the pane, get a child, essentially get a location, and add to it a new image view with this image. So right now, essentially, I added the us.gif image to the pane. Image 2 is same idea. I'm setting some fit height and width. Again, you can play with these and see how they work as far as the size of these images. And then you add image view 2, and then image view 3. Again, put the pane onto the scene, and then put the scene onto the primary stage. So as you might expect, I'm going to get some pictures or some images because of this, and this is what we get. So you get the US flags and O and the X. Now notice if I go in here and say, well, I want to change my image size or the insets gap to 25, you could easily do that. And so the gaps are like that in 25. Now one thing you can do, which is kind of neat, is I could go back in here, change these to back to 5s. So you can compare and contrast. So I can compile this, and when I run it, I'm going to get a new window, essentially a new image. And now I could, look at these side by side. So can you tell the difference between these two? It looks like this has a smaller gap on the top and the left and the right, and this one has a larger one. This is with the 25 gap. This is with the 5 gap. So that's what we mean by those insets and the gaps between them. So that's kind of nice because you could run these things in different threads or essentially their own programs, and then you can compare and see how they behave. Okay, so this is the example on show image. If I go in here, the next thing is, I think I'm going to go back all the way to where I left off on the show image. This is what we're talking about, the layout panes. Pane is the base class for the layout. It contains the getChildren method, and that's what we had to say, pane.getChildren, so we could add nodes to it or add components to it. So a stack pane essentially places the nodes on top of each other in the center of the pane, so not very useful. Flow pane places the nodes row by row horizontally, or column by column vertically. So as you might expect, a flow pane, essentially all it does is just starts from here and starts filling to the right, and then when it runs out, then it goes to the left and starts filling out. Again, this is depending on how many or what sort of nodes or components you're adding. A grid pane essentially puts the nodes in a two-dimensional grid. So essentially, think of a grid pane as nothing but a table. So if I did this, then it will place the nodes in this way. Now, one thing that you're going to see is that on a grid pane, so remember these things right here are called columns. And of course, these things here, the horizontal ones are rows. So you have columns that are vertical and horizontal. And this is column, essentially cell 0, 0. And then this would be, so if you could think about this as, if this is row, then that would be row 0, column 1, row 0, column 2, etc. So this would be row 1, column 0, row 1, column 1. So you get the picture. So that's what this grid pane looks like. Horizontals are row and verticals are columns. And so let's go back in here. So that's what grid pane is all about. Border pane places the nodes in the top, right, bottom, left, and center regions. So essentially what the border pane does is it's going to say, okay, I'm going to take your window, and this is my top region, this is my left region, center region, I have a right region and a bottom region. So that's what that border pane does. And then the nice thing is, of course, each one of these could have their own top, left, and so on. So essentially, as you can think about this, is that you could just start to create more complicated, essentially, user interfaces by creating additional panes and using this border pane method of placing nodes on the window. Okay, so HBox places nodes in a single row, VBox places row in a single column, which we already talked about. So if I go in here, there is a example. Again, your book gives you a whole bunch of examples. I'm going to show you this, go over this show grid pane.java. And notice again, here we're just saying grid pane, pane. Remember before we used to say stack pane or pane. Now we're saying grid pane. So all it says pane looks something just like this. Okay, and remember these are all dynamic, so I don't have to tell it up front how many rows and columns to use. Again, when you get a chance, play with these settings on that pane. Things like setting the inset gap and then the horizontal and vertical gaps. So here I'll say pane.add, new label, first name, 00. Now notice the way this add works is that the first index represents a column and the second one represents the row. So this is really goes to column 0 and row 0. So middle initial goes to column 0, so and row 1. So where's column 0? Row 1. So that's where that middle initial is going to go. And then the last name is going to go right next to it on the essentially line up the first column of our grid. So the column 0 stays right here. In other words, we're going to move it, so this is exactly the opposite of what we were just talking about, is that we're going to fill this according to this setup. The first one goes to column 0, column 0, column 0. Is the only thing that we're changing is the row numbers. So that's how we're actually filling them this way. And then if we go back to my Java program, I have a text field. Now text fields are essentially nodes or components where we can actually type text in. And if you notice, these text fields are going to go to the second column, and then the rows go 0, 1, and 2. Okay? I have a button that goes to column 1, that's the very first column, and row 3. So if I ran this, what you're going to see is a more organized way of these buttons. I'm going to go ahead and resize that. So notice first name, middle initial, last name, they all occupy the first column. And then all those text fields went to the second, essentially, row. And then this add name by default is left justified, but it is on the third, essentially in this case, it's going to be the fourth row of this table. Now, again, we're not actually, this add name doesn't have any control or any action to really do this. And then we cover handling actions in CIT 230, where we actually click on add name and maybe we'll save all of this in a file or even in a database. Okay, so that's show grid pane. Now, if I go back here, I think I have this example for my flow pane. Notice how this works. I've got labels and text fields, and you can tell that they start from left to right, and they just fill the. So if I start adding more components, more controls, they just go to the next row. Notice as I resize this window, they automatically adjust. So they really don't look good all the time, but so that's why that grid pane looks a lot better, because we have a lot more control on a grid pane. I suppose I should change this to change my label, because that was misleading. This is really a flow pane. Again, that's just a label, so you can tell how that goes. And finally, make sure it compiles. Finally, what we want to do is I just wanted to show you some shapes. Notice I have a circle. I have another circle. I have a rectangle. I'm changing, set the stroke to black. I'm changing its color to yellow. Polygons are another set of shapes. Essentially, a polygon is any shape. Could be represented by a set of points. So if you open up page 570 of your textbook, you'll see a good example of how these coordinates work. But essentially, if you can imagine, this is coordinate 40, 20. So if I go in here, 40 would be around right there, 20 would be around there. So that's the beginning of my first point. Then I go to my text pad, and where's the next point? 70 and 40. So if I go in here, 70 would be around here, and I think the other one was also 40. I forgot already. 40, 20, and 70, 40. So it's just going to be right around there. So what it's going to do is it's going to draw a line like that. So if you have a grid paper or one of these engineering papers, this looks a lot better to design that up front. So essentially you design your interface up front, and then you write code to essentially mimic your design. So when I do this, I'm going to add a polygon, a rectangle, and a couple of circles. So notice when I run this, this is what I'm going to get. Okay, again, you can play with the shape of these things, and essentially you can make this larger by larger radius. This is the width, and this is the height, and so on. By the way, in real Java life or Java programming life for graphical user interfaces, we use IDEs like NetBeans and Eclipse that actually allow us to essentially drag and drop rectangles and polygons and various shapes, and then we can associate the events with those and then write the code for every event. By event I mean if a button is clicked, or if a menu option is selected, or if we check a radio box or a checkbox or things like that. Again, those will be these concepts will be covered in CIT 230. Okay, so hopefully this makes some sense. I just wanted to make sure that you understand. Again, a node is essentially a place, a container to hold. You can hold shapes, and shapes would be any one of these among other stuff. So text and lines and rectangles and so on. So then your book talks about the text, lines, rectangles, circles, ellipses, arcs. Arc examples. This is what I was talking about polygons, by the way. That's the book page that I mentioned. That's what this is. So it's highly suggested that you actually, all of these files, by the way, are in your student data files. So you should be able to open these up and compile them and run them and play with them. And of course, if you have any questions, you'll put your question in the forum. And then they have a case study with a clock pane, so if you get a chance, run this and see how this works. It's kind of a nice example of putting everything together, essentially. Again, remember that this doesn't have any, doesn't do anything as far as events are concerned. So if you click on a clock, on the clock, nothing really happens. Okay, I'm going to go ahead and stop here. I hope this was helpful on understanding this basic idea of creating graphical user interfaces in Java. Okay, goodbye for now.